Right, so after watching this video, you should be able to create a stem and leaf plot, determine the median and mode from a stem and leaf plot, and also contrast two different data sets represented in a back-to-back stem and leaf plot. Right, the key things you'll have to remember from previous work is how to determine the median score. So by adding 1 to the number of scores, so adding 1, and then dividing that by 2 to get the score that's the median, and then just counting it out. The other thing to remember is that the mode is the most common score. Right, stem and leaf plots are useful ways of displaying discrete data. So discrete data means it's numerical and that there's set values. They are exact set defined values. Now the final digit, when you've got a number in stem and leaf to use in the stem and leaf plot, the final digit is called the leaf, and the leading digits are called stems. So for the number 152, the stem would be 15, so all the numbers in front of the last digit, and the leaf is just the last digit on its own, that 2 there. Now when creating a stem and leaf plot, the data is organized into rows so that all the items with the same stem are in the same row, and then all of the leaves are ordered from smallest to biggest. Now, often to make sure you get all the numbers in the data set written down, I often do a rough draft. So just making sure all the numbers are in the right row. And then once you've got the numbers all in the right rows, you can then convert it into a good ordered second draft or final copy of your stem and leaf plot by ordering each row one at a time. I'll show you what that looks like in an example. The other thing you'll have to do is include a key that explains to the reader how the numbers work. So let's say we've got our original number, 152. Our key would say 15 with a line between it 2 equals 152. And that's all that's required for a key, just to show what the numbers actually mean and what they equal. All right, so we've got an example here. We've got the maximum temperatures for the first 14 days of February of 2021. So what we've got to do is create our stem and leaf plot. So there's our stem, there's our leaf. So what I'm going to do is just put the data in the right rows to start off with, and then rearrange them from smallest to biggest. Now looking at the data, I want to check out the stems and see what the smallest numbers are. So 25 is a pretty small stem. 35 is a pretty big stem. Is there anything else in there that's bigger or smaller than those values? No. So that means my stems need to go from 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So not nearly long enough, but we'll just make that a bit longer there. So that'll need to be in my rough draft, but also in my final. So in my final draft, that'll be 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. Unfortunately, is at the very bottom there. Now let's go through and do the leaves. What I'm just going to do is just get all the data into the first table, not really worrying about the order, and then I'll order it on my second. So 29.7, so that'll be 29 and a 7 there. 25, 7 will be a 7 there. 29, 1 will be a 1 there. 30, 0, 0 there. 29, 7, 7 there. 31, 1 there. 35, 2 there. 29, 6 there. 29, 1 there. 28, 5 there. 27, 6 there. 31 there. 37 there. And 32, 30.2 there. Now what I want to do now is just order that data from smallest to biggest in each row. So 25, it's just the 7. 27 is just the 6. 28 is just the 5. Now this next set, I'll need to order from smallest to biggest. So I've got 2 1s, a 6, and 2 7s. In the 30 row, that'll be 0, 1, 2, 7. 31 has a 1, 35 has a 2. And there's my stem and leaf plot for my data. So I've got all the same stems, so all the numbers with the same stem in the same row, and then each of the leaves is ordered from smallest to biggest. The only other thing I really need is a key. So here I'll just pick out the first number. So 25/7 actually means 25.7 degrees Celsius. Right, so 25, and then that line in between with the 7, it's 25.7 degrees Celsius. Determine the mean. All right, so let's use a different color for that one. So to find the median, sorry, not the mean, find the median, we need to find our middle number. So remember how we do that is we take our number of data points, which in this case is 14, add 1 over 2 is the 7.5th score. So that means our median will be between the 7th and 8th score. So just counting them through in our stem and leaf plot, and this is why it's important to have them in order. That means you can just count through your stems, your leaves in order. So 1, 2, 3, 4, 5, 6, 7, and 8. They're both the same number, which is really handy. So that means our median is not 7, right? It's actually 29.7. 29.7 degrees Celsius, because it's smack bang, yeah, in the middle of 29.7 and 29.7, which is just 29.7. Now the mode is the most common, or the number that appears the most. In this case we have 2. We have 29.1 degrees Celsius, and we also have 29.7 degrees Celsius. They both occur twice. 29.1 twice there, 29.7 twice there. And that's how we determine the mode. Right, now we can actually also use back-to-back stem and leaf plots to compare 2 or more data sets. So let's say we're comparing the first half of February and the maximum temperatures there, and then the second half of February, we've got the temperatures on the left. So what are some things we can say about the data? Well, some things that strike me first off is the range in the first half of February is much bigger. It goes from 25.7 all the way to 35.2. Right? So that's a good thing to start with. The first half of February has a bigger range than the second, and actually saying what that range is, it's ranging from 25.7 to 35.2. Now, if we don't consider those parts of the range, right, these values are pretty consistent, right? So if we don't count the items at the very low and very top end, the rest of the data is pretty consistent. So we can say that for the first half of February, most of the data, generally speaking, it falls between 27.6 and 31.1 degrees Celsius for the first half of February. Looking at the second half of February, it actually generally varies between 27.4 and 33.7. It's a lot more consistent, right? All the data it's not quite as spread out as in our first example, right? So the spread in the first half of February was much higher than the spread in the second half of February. And we can see that because the numbers aren't quite so spread out in the second half of February. And so we can say the temperatures in the second half of February were more consistent. They don't vary as much. There's not as big a range there, varying just between 27.4 degrees and 33.6 degrees. And that means actually that generally speaking, in the second half of February, the temperature was actually hotter because we have more values on that high end compared to the just one value on the first half of February. Right, so after watching this video, you should be able to create a stem and leaf plot, determine the mean and mode of a stem and leaf plot, and also contrast two different sets of data represented in a back-to-back stem and leaf plot.